by four past plates. It's called Bohr idea given to the above structure of an atom is called as past plates of Bohr atom. அவர் சொன்ன ஐடியாவில் என்னென்ன அப்படிங்கிறத சொல்றாங்க. அங்கே என்ன சொன்னாங்க அப்படின்னா எலக்ட்ரான்ஸ் வந்து ஸ்டாட்டிக் தியரி டைனமிக் தியரி எல்லாம் பார்த்ததுக்கு அப்புறம் electrons are not in the rest. It is moving in a atom, inside that atom. That was explained by Rutherford. Bohr explained that electrons in an atom moves around the nucleus in a circular orbital. So you know that if the particle is moving in a circular orbital, circular motion, definitely it has the centripetal force. So the centripetal force gives the electron to undergo move in a circular motion. That's first idea given by the Rutherford. Next thing is, electrons in an atom revolve around the nucleus only in a certain discrete orbitals. So electrons are revolving in a various orbitals, but it has the discrete orbitals. And discrete orbitals has the particular energy. That means it has a discrete energy levels for each and every electron in different orbitals. So that energy possessed by the electron does not radiate the electromagnetic energy. Only those discrete orbits allowed are stable in the orbit. Suppose the electrons are jumped from that one orbital to that another orbital, that energy can be emitted or absorbed. See here that all the electrons have the energy, this is discrete set of energy. That energy equal to that multiples of h by 2 pi. Where here h is the Planck constant and h by 2 pi is the energy of the discrete set of that energy of the electron. That is quantized. Quantized means அதுக்குன்னு அவ்வளோ எனர்ஜி கொடுத்துருக்கிற மாதிரி இருக்கிற மாதிரி எனர்ஜி possessed by the electron. So that integral or integer means so all the electron have the same energy, but integral multiples means 1 into this value or 2 into that value. So we can write it as nh, where n equal to 1, 2, 3, 4 like that. So n is the principal quantum number. See here, L is the angular quantum number, where L is equal to n into h grass. We can write L into h grass. H grass means h by 2 pi. That is a short form. We can write h grass. H grass equal to h by 2 pi. The condition is known as angular momentum of quantization of condition. So in 7th lesson, we have studied that the electron revolves around the nucleus. It's not in a linear motion. It is in a wave form. It's not in a circular motion. It is in a wave form. See that 7th lesson already we know that. So here, so you can take this first picture. Electrons are moving in a circular path, but in a wave form. See, so this is a wave. So here is moving like this. So how many waves is there? You know that one wave means one thrust and one trough. So this is one wave, two wave, and three wave. So the total circumference of the circle has the three waves. So where we go, so you can write n equal to 3. So from center of that atom to that path is radius r. So number of waves is 3. So wavelength, you know that one complete vibration of the particle. From here to here, this is called one wave. So that wavelength equal to lambda. So total 3 waves. So n equal to right 3. Here 5 waves are there. N equal to 5. See here, it is not 3. It is 3.3. It is not a complete wave. So you can take that is only small portion is that is 3.3. Okay. So this is a waveform of the electron inside the atom. So now we are going to prove the Bohr atom model. So how we have to prove? Let us see. See here, that electrons are revolves around the nucleus of a circular orbital. So the path traveled by the electron in a circular path, that is equal to 2 pi r. So the 2 pi r you can write. The 2 pi r is equal to wavelength. So what is the number of wave? 5. So 5 lambda. Suppose it is 3 lambda. So you can write the 2 pi r is equal to n lambda. Commonly we can write n equal to 1, 2, 3, 4 like that you can write. So commonly you can write n lambda. Or lambda equal to, so here lambda equal to h by mv. This is for 7th lesson, de Broglie wavelength. We derived that equation. Lambda equal to h by mv. So substitute that value lambda here. So what will happen? 2 pi r n lambda instead of lambda h by mv. Or you can write nh by 2 pi இங்க இருக்கிறத எடுத்து வந்து கீழே வச்சிடறோம், mv இங்க கொண்டு வந்துடுறோம். So mvr equal to nh by 2 pi. So you know that linear momentum, product of mass into velocity is called momentum. That is linear momentum. Angular momentum. A moment of linear momentum is called angular momentum. Moment of linear momentum is called angular momentum. That means the linear momentum is multiplied by the radius r. You will get angular momentum L. So L equal to r into m into v. So instead of mvr, we can write L. So suppose you are writing that mvr instead of L, you can write that is equal to n h cross. So delta E, delta E means E is the energy, delta E is change in energy when electrons are jump from the one orbital to the another orbital. So the two energy levels, see, electron is initially it is in the ground level. When the energy is given to that electron, that is h mu is the external energy. That energy is given to the electron. So the electron absorbs that energy, it jumps from the ground state to the excited state. So it is in the excited state. See, it is in the E, yes, that is excited state. After emitting the radiation, h mu, that energy is radiated. After radiated that energy, that electron comes to the ground state. So E final minus E initial. So electron in final state minus initial state. The change energy h mu equal, that is h mu. That is radiated energy h mu. That is the difference between the two orbitals or the two energy level of the electron. So h mu, or you can write h mu, instead of mu you can write c by lambda. You know the relation, c is equal to mu lambda. The formula is c equal to mu lambda. So mu equal to c by lambda. So we are writing here h into c by lambda. Okay. So that is the thing. Second thing explained by the Bohr atom model. So using that, we can calculate the discrete set of the energy in each orbital, and that energy change in energy when electron is jump from the higher state to the lower state. So this is the third thing explained by the Bohr atom model. Now we are going to see that radius of orbit of the electron and velocity of the electron. So electron on the circular orbital சுத்துதுன்னு. So what is the radius of the electron and what is the velocity of the electron? Velocity சுத்திட்டு அப்படிங்கிறது நாம் பார்ப்போம். Okay, now listen. So radius of the orbit of the electron and velocity of the electron. Now you can consider that this is the electron. So on the center of the atom, it has the nucleus. So proton is assumed to be a stationary. It's not in the movement, so it is in a stationary. So it has proton and neutron. So electrons are revolved around the nucleus in a circular orbit. So the velocity of the electron is taken as Vn. The radius of the electron is taken as Rn. So electron revolves in the nth orbit. The radius of nth orbit Rn. We can write radius of the orbit is R. Nth orbit means that is Rn. Okay. So now we can write that equation. First thing. So here positive charge is here and this is negative charge. So there is a force acting between the two charges, that is called Coulomb force. So universal gravitation law, you know that is F is equal to K into m1 m2 by r square. Like that, here universal gravitational law, like that, it is a Coulomb force, that is K into q1 q2 by r square. So where K equal to 1 by 4 pi epsilon r, is an E, that is q1 equal to, we can take as proton. Is that number of proton, the charge equal to E. The positive sign indicates that is a proton. Minus E, that is electron, negatively charged, so negative sign is there. Rn square, that is the radius of the electron, Rn square. R cap is the unit vector that will indicate the direction of the electron. So we can write that 1 by 4 is not negative sign is here, that you can write right here. Is that E square, R square n R cap. Next one, when the electrons are revolved around the nucleus, it experiences the centripetal force. Centripetal force equal to, you know the formula for centripetal force. F centripetal force equal to m v square by r. So Vn, Rn is here, r capital is the unit vector. Here the two forces, Coulomb force and centripetal force, are equal. Otherwise what will happen? That electrons are ejected. So you know that in circular motion we already studied in the 11th standard. Circular motion produced now. So up to the two equations is equal, that electron remains in the same orbital. So definitely it is equal. So we can equate the two equations, centripetal force and that equation of motion. So using that equation you can calculate that Rn equal to 4 pi epsilon naught. So here Rn equal to 4 pi epsilon naught m Vn Rn whole square z m e square. We know that angular momentum m Vn Rn equal to L is the angular momentum, that is equal to n h cross. So here Rn equal to this equation is here, that is same equation. Instead of that m v r n, we can write that is L n. Okay, or we can write n h cross. Here they are writing n h cross. So n h cross whole square. Simply we can write n h cross the whole square. Say next thing, is it n square remains same? So we can put square on the two things. Okay. Next thing is h cross equal to, you know the value h by 2 pi. So suppose you are writing that h by 2 pi, it is the square. So h square by pi square. Here one pi is there. So pi get cancelled. So remaining pi square is there. Here 2 is there. Squaring that value will get 4. So 4 and this 4 will get cancelled each other. Okay. So remaining value you can write Rn equal to A0 n square by z. Where A0 equal to, this is the A0. Epsilon naught h square by pi m e square. All these things are constant values. Okay. These things are constant values. So substituting all the known values in this equation, you will get 0.529 angstrom. Or you can write round of this value 0.53 angstrom. Okay. So radius of nth orbit Rn equal to A0 n square. Simply you can write A0 n square by z. Okay. Here z equal to, you put 1 for an hydrogen atom. You will get Rn equal to A0 n square. So this is the value. So this is mass value. For R1 means first orbital. First orbital you put n, instead of n you put 1 square. So A0 only is here. A0 equal to, you know the value, 0.529 angstrom. Suppose second orbital n equal to 2. Here 2 square. 2 square means 4 A0. So you will get this value. Suppose you are to put 3, that third orbital, 3 square, 9 into A0. So you will get this value. So 4, 5, 6 like that you can increase the value. You can calculate all the radius of that orbital. Here the radius of the orbital is directly proportional to the n square. So number of orbitals increases, the radius also increases. In this equation, see m Vn Rn equal to, instead of Rn you can write A0 n square. That is also equal to n h cross or n h by 2 pi. So roughly you can draw the diagram. This is for the atom. There is R1, R2, R3 and R4. So R1, R2 equal to 4R1, R3 equal to 9R1, R4 equal to 16R1. Suppose R5 is there, that is 25R1. Like that it will increase. Okay. So in this topic we calculated the radius of an atom. In next thing is we calculated the radius. Now we have to calculate the velocity. So in this equation you can write Vn equal to, so already Rn is the radius, we calculated already that. Now you can write Vn. So here Vn is here, see, it's a Vn. Vn equal to, you can take all these values on the other side. So you will get the equation of Vn equal to h by 2 pi m A0 z by n. Here in this equation, you know that velocity of an electron is inversely proportional to n, where n is the number of orbitals. We can put 1, 2, 3 like that. So n equal to orbital. So velocity increases, that orbital decreases. Number of orbitals decreases. When number of orbitals are increases, velocity decreases. So velocity and n is inversely proportional to each other. This can be explained in that graph. See that graph. So number of orbitals in x-axis, velocity in y-axis. So that velocity is gradually decreases when n increases. So these two things are inversely proportional to each other. So one thing is increases, another one is decreases.